Hello, everybody. Mr. Thomas here. Welcome to episode 4 of Mr. Thomas's class. What we are going to be focusing on today is math again, and we're going to be looking at two concepts on fractions. The first is going to be equivalent fractions, and then we are going to do a little bit of work with adding and subtracting fractions. So we're going to be talking first about equivalent and equivalent fractions. So in the word equivalent, the first three letters, E, Q, U, they stand for equal or balance. This comes from a Latin root word. So equivalent means fractions that are equal to each other. So let's take a quick look. We can make 1/2. And we can make 2/4. And there's a couple ways we can go about this. One we can do is to draw a simple shape. I can draw a square to represent each one. Move this up so you can see. And another square. And if I shade half of this, and if I take this shape and I split it and I shade 2 out of 4, you can see that those are going to be equal to each other. So we would say that 1/2 is going to be equivalent to 2/4. Let's take a look at this problem. So we have 4/6 and we have 2/4. We can try the strategy I just showed. So draw a square to represent one whole. 6 and 4, the denominators are both an even number, so I can split each of those squares in half. This one I need to split into 4 equal parts. This one I'm going to need to split into 6 equal parts. I'm going to shade in 4. 1, 2, 3, 4. And then here I'm going to shade in 2. 1, 2. So if you were to look, 4/6 goes down a little bit farther than 2/4 does. If we were going to use the concept we did last time, we could say that 4/6 would be greater than 2/4. Another way to refer to it, if we're talking equivalent, you would draw an equal sign, but then you draw a line through it, which essentially means 4/6 is not equivalent to 2/4. We can also use the same strategy that we used when we were comparing fractions. So what I would do is draw my rectangle that stands for one whole from one side to the other. 4/6 is going to be our top portion. 2/3 is going to be the bottom portion. So I know that 6 is an even number, so it has a midpoint. So I'm going to have to split this into 3 equal parts, and this into 3 equal parts, and then the bottom portion I have to split into thirds. So we continue this line down, now we continue that line down. I'm going to shade in 4 parts on top, 2 parts on the bottom, and you can see they go to the same point. So in this case, I would say that 4/6 and 2/3 are equivalent to each other. Now we're going to switch gears a little bit and go from working with equivalent fractions over to adding and subtracting fractions. For 3rd grade, this is actually a pretty easy concept, because the denominator stays the same when we're talking for fractions in 3rd grade. It does get more complicated as students move up to 4th and 5th grade and above. But for 3rd grade purposes, if we're talking fourths, if I had said 1/4 plus 2/4, you leave the denominator alone. So in that case, it would stay a 4, and you simply add the numerator. Add 1 plus 2. So you would say this is 3/4. The same idea applies when we're subtracting. So if we were talking about 6, if I said 4/6 minus 3/6, we would leave the denominator alone. So it would remain a 6. 4 minus 3 would be 1. We're going to try one more addition problem and one more subtraction problem for fractions. So again, the rule that applies is you leave the denominator, the bottom part of the fraction, alone. We're talking eighths here. So I would leave my 8 alone. 1 plus 4 would be 5. 2 more would be 7. So the answer here for 1/8 plus 4/8 plus 2/8 would be 7/8. When we're talking subtraction, again, the same thing applies. You leave your denominator. We got a 10. 7 minus 5 would be 2. So 7/10 minus 5/10 would be 2/10. Now, as students get a bit older, you don't have to do this in 3rd grade, but there's something called reducing a fraction, which is going to make a fraction a bit smaller. This can also be called 1/5, and then that ties into equivalent fractions. 2/10 is the same as 1/5.